Trig functions are called circular functions because we need to use a circle to define how we draw their graphs. So we're going to start in on that by looking at this circle here. Notice that it is a circle that has a radius of 1. We've marked it out in tenths with a XY grid superimposed on the circle. Looking at this red line here, you might see this angle looks like it's about 30 degrees. So let me explain to you that it is exactly 30 degrees, but I want to kind of back up before I explain why. So let's think about what we've learned about a 30-degree angle in the past. So let's draw our 30, 60, 90 special triangle. Here's the side 1. If this is 30, that's the side 1. Here's square root of 3, opposite the 60-degree angle, and here's 2. Now, if I were to put that same triangle on my circle here, and if this were indeed 30 degrees, notice that the radius here is 1 for this circle, which means the hypotenuse of any triangle I draw inside the circle like this is going to be 1. So how would I take my 30, 60, 90 and rescale it to a similar triangle that has a hypotenuse of 1? So if this hypotenuse is 1 right here, then what do I have to do to the other two sides? Well, notice I would have to divide each side by 2. So I divide the sides by 2. This would give me 2 divided by 2, and that would give me 1. Then this side would have to be 1 divided by 2, which is 1/2, and this side would have to be the square root of 3 divided by 2, which is approximately 0.866. So if we were looking at this triangle here, if the hypotenuse is 1, we would expect the opposite side, or the vertical side, to be 1/2, and it is. If you look over here, 0.5, this is 0.5, or 1/2. The adjacent side we would expect to be about 0.866 units long. Notice that looks very reasonable. So this is 0.866, or the square root of 3 divided by 2. Now, something else to notice about this right triangle here is because its radius is 1, or because the hypotenuse of the triangle is 1, if the adjacent side we call x and the opposite side we call y, and this is my angle theta right here, this is 30 of course here, but in general if we just had a triangle drawn in here at some other angle, notice that cosine of theta is just going to be x over 1, and sine of theta is going to be y over 1. So cosine of theta equals x over 1, which is just x. Sine of theta equals y over 1, which is just y. And I'm kind of writing in this corner here because I'm going to be needing some space right here. So when I label these points, and I'm going to label them as square root of 3 over 2, 1/2, the x-coordinate is just going to tell me the cosine value. This is cosine of 30. And the y value is going to tell me the sine of 30. Because if I go back to my original triangle, sine of 30 is 1 over 2, cosine of 30 is square root of 3 over 2. If I looked at the triangle that has a radius of, or a hypotenuse of 1, because the radius of the circle is 1, cosine of 30 is 1/2 over 1, sine of 30 is square root of 3 over 2 over 1. Same thing. Cosine of 30 is just going to be the x-coordinate, and sine of 30 is going to be the y-coordinate of the point at the corner of the triangle. Now what if I did 60? Okay, so let's look at a 60-degree angle. I'm going to go down to the bottom for this because I don't have enough room to do this elsewhere. Well, maybe I can fit it over here. Square root of 60, not square root of 60, sorry, angle measurement of 60. So angle measurement of 60 here. This would be 1, this would be square root of 3, and this would be 2. Now, once again, if I wanted to fit a 60-degree angle inside my triangle, the radius would have to equal 1. So I have to divide everything by 2, so the radius, or the hypotenuse of the triangle, is equal to 1. So this tells me that the adjacent side is 1/2 and the opposite side is the square root of 3 over 2. So if I go over 1/2 in the x direction and I go up to where it intersects the circle, and notice that is 0.86. 0.86. Then this is a 60-degree angle. 60 degrees. This is the square root of 3 over 2, 1, and then from the distance in the x-axis is 1/2, okay, 0.5. So the coordinates of this point would be positive 1/2, positive square root of 3 over 2. Just think about plotting a point. Starting at 0, 0, I'm going to go over 0.5, which is 1/2. Then I'm going to go up 0.86, which is the square root of 3 over 2. So this is the cosine. The x turns out to be the cosine of 60, which is 1 over 2, or 1/2 divided by 1. The sine of cosine is square root of 3 over 2 divided by 1, or square root of 3 over 2. Same thing. Now let's transfer these coordinates then from our 30 and our 60-degree angle. So here's 30, here's 60, and I guess to be consistent I'll put this in black. Let's find all the other angles that have a 30-degree reference angle. So we have another one in quadrant 2 at 150. How are we going to draw it? Well, we know the opposite side has to be half of the hypotenuse. So we're going to go to 0.5 on the y-axis, go over to where that intersects the circle, and go straight down. There's our side, there's our opposite side that's equal to 1/2. Notice our adjacent side is equal to 0.86. So the coordinates of this point are going to be negative square root of 3 over 2, negative 0.86, positive 1/2. And this is a 150-degree angle because this is a 30-degree reference angle. Now if we go into quadrant 3, we're going to go to negative 0.5 in the y direction. So if we go over to where that intersects the circle right here, this is 1/2. This is negative 1/2 down here. And this is still the square root of 3 over 2. That's negative, sorry, square root of 3 over 2. And we draw this down here. Another 30-degree reference angle. This is the angle 210 degrees. It has the same coordinates as the other two, except both of them are negative now. So negative square root of 3 over 2, negative 1/2. Then if we go into the fourth quadrant, go over to, go down to negative 0.5, go across to where it intersects the circle so that my opposite side is negative 1/2. Draw in the rest of the triangle. Positive square root of 3 over 2 is my x, negative 1/2 is the y. This is also a 30-degree reference angle. This is 330 degrees. And these, now we have a positive square root of 3 over 2 for the x, and then a negative 1/2 for the y. Now let's fill in the 60. So if we go to negative 1/2 for x, so this was positive 1/2 square root of 3 over 2. Now we're going to go to negative 1/2 square root of 3 over 2. So negative 1/2 square root of 3 over 2. I had to kind of cut that to leave room there for my label. So this would be a 120-degree angle because I would have to go another 60. So if I start here, go all the way around to 120, I would have to go another 60 degrees to get to 180. So this is 180, of course, right here. So this one would have the same two values for x and y, except that x is going to be negative now. So this is negative 1/2 positive square root of 3 over 2. Then if we go down to quadrants 3 and 4, now we're going to positive 1/2 negative square root of 3 over 2. This is 240 degrees. It has a 60-degree reference angle. We're adding 60 to 180. Here we subtracted 60 from 180 to get to 120. And then my two coordinates are going to be the same thing, only both negative now. So negative 1/2, negative square root of 3 over 2. Quadrant 4, go to positive 1/2, and the y value would be negative square root of 3 over 2. This would be the angle 300, and it has the coordinates positive 1/2, negative square root of 3 over 2. Okay, so these are the special angles on what's called the unit circle, on a circle with radius 1. Remember, the importance of a circle with radius 1 is this. If I have an angle drawn inside of a circle, like this, so, I'm going to draw that a little better. Let me draw the circle first. So if I have kind of an XY axis and then I have a circle, okay, like this. So here's the XY axis in the circle, and I put an angle in here, and the radius is 1. That means the hypotenuse of the triangle is going to be 1, and I call this X and Y for the adjacent and the opposite sides. Then I know that cosine, and this is my angle theta, that cosine of theta is going to be adjacent over hypotenuse, X over 1, which is just X. Sine of theta is Y over 1, which is just Y. So my XY coordinate tells me the sine and cosine of theta. X tells me cosine, Y tells me sine. So we're going to extend this now to the 45, 45, 90 triangle. So I'm going to do this a little more rapidly, and then we'll move on to putting it together. So here we have a 1, 1, square root of 2 triangle for our 45-degree angle. I want to fit this on a circle where the radius is 1. So that means the hypotenuse of the triangle is going to be 1. So if I were to rewrite this, I would have to divide every side by radical 2. Because I want the hypotenuse to be 1, so I'm going to have to divide the hypotenuse by itself, which is radical 2. So if I divide by radical 2, the hypotenuse becomes 1, and the two sides become 1 over radical 2. Well, it makes sense that cosine of 45 is 1 over square root of 2, sine of 45 is 1 over square root of 2, which is the same as saying cosine of 45 is 1 over square root of 2 divided by 1. Same thing. Sine is 1 over square root of 2 divided by 1. So a couple other things I want to point out is that this is the same thing as the square root of 2 over 2. If I multiply both the numerator and denominator by radical 2, I get square root of 2 over 2. And this is also approximately 0.71. So the square root of 2 over 2 is the form I'm going to use. And this will establish a pattern later on. So this is what I want to show you, that later in the next step, I'll show you this pattern. Now, if this is equal to 0.71, then if I go over 0.71 and up 0.71, I should see this, that the coordinates of this point are both about 0.71, or 1 over square root of 2, or square root of 2 over 2. So this is 0.71, which is square root of 2 over 2. So this is also square root of 2 over 2. Okay, it's also 0.71 up. All right. So that means the coordinates of this point are the square root of 2 over 2 and the square root of 2 over 2. This is a 45-degree angle. If I draw 45-degree reference angles in the other three triangles, in the other three quadrants, I have exactly the same proportions for the sides. It's just that in quadrant 2, the x value is now going to be negative. So this is the angle 135, and I have negative square root of 2 over 2, positive square root of 2 over 2 for the x and y coordinates. When I go into quadrant 3 and add 45 degrees, okay, so this is 180 minus 45, this is 180 plus 45, I'm going to end up with 225 degrees, and the coordinates of this point are both negative. Negative square root of 2 over 2, negative square root of 2 over 2. Last angle is 315 in quadrant 3, and the coordinates of this are going to be positive square root of 2 over 2 for x, negative square root of 2 over 2 for y. Once again, the x value tells me the cosine of the angle. The y value tells me the sine of the angle, and the reason why that is because the hypotenuse is 1. So we're going to put this all together on something called the unit circle in the next video.